What's up, guys? Ivan here with getivan.com. In this video, I'm going to be showing you guys a newish method that I have for using address regex to get more precise um, data contacts from a particular area. So I talked in one of my previous videos about regular expression and the premium email scraper for Scrapebox. And since then, of course, I've run some orders and done a small number of scrapes using address regex. And so I've been experimenting between using the on-page location sort of filter to scrape emails versus using the address regex to collect the addresses, and then using the URLs from those addresses to then scrape contacts. And I wanted to show you that method real quick. Kind of talk briefly about the pros and cons. I have an order that I've been processing, so we'll look at my Blue server for the purposes of this video. And in this particular order, so this is really only for highly localized scrapes. So if you want to get data from very specific locations, then this works really well. So for this particular order, we had a lot of niches. So the customer, this is an actual client order, wanted to have as many niches as possible in 25-mile radius around Tampa and also Orlando, Florida, which produced this quantity of locations, 92 cities. And the number of keywords I used was roughly 1,200. So pretty good, solid list. And I'll put a link to that list in the description below. And so anyways, those permutations, you can see 92 by, 1248. So 1248 by 92. And then the depth was, I think, 11 or 12 results deep. And so we have 1.377 million URLs. And this was really just based on the order level that this particular customer wanted to purchase. So obviously you can go a lot more, but they wanted a lot of different niches. And so because the number of niches was so high, we had to, kind of correlate that with the number of locations they wanted to target and then try to figure out what's the maximum depth we could achieve. So it was only about a little bit, just a tad more than the first page of search results. So really the goal is to get as many different contexts as possible across a large number of niches, right? So then the challenge is, this is the point of this video, to show you guys, okay, so we're going to get a lot of data, but then how do we make sure it's legitimately from those niches? Because a common problem is you might have, say, this city here, Winter Springs, Florida. And there might be another Winter Springs somewhere out there in America or even in Europe. And so if Winter Spring, now on the first page, you're probably not going to run out of results, but you never know. Oftentimes, though, this kind of search might pull in results from another place entirely. It might not pull results from Florida. It might pull results from Winter Springs, Colorado, if such a place existed, or Winter Springs, England or something like that. Who knows? It varies. And so you have to have some sort of filtering mechanism, whether it's by on-page filtering or by, say, this address method. So if we go to grab check here, this would be the on-page version for grabbing emails. We would go to set filter, and then we would fill a variety of location-oriented permutations into this region. So in my case, even though we only had 92 locations, we created, let's see, over 704 different permutations of those locations. So we had city space state abbreviation. We would have city comma space state abbreviation. We would have city state name, city comma space state name. You see, and then I also included a variety of zip codes, since zip codes seem to also deliver pretty similar results. And so this would be one way to do it, is to create permutations. You can do that by just coming into a text file and going Control H to find and replace. and you can just say, okay, I want to find space Florida, and I want to replace that with comma FL. And you can basically do that 4 times and pretty much get a variety of the permutations that you would, or a few, you could do that until you have the permutations you desire. You can also use a permutations tool by going into Scrapebox, into this region here, and you could have a text file that just had your cities. So you could come in here and go, I want you to find Florida, and replace it with nothing. And then that would just give you your cities, and you could save that as a separate file. Let's go ahead and do that as an example here. Don't save. Open my blue. I use this blue server text. This really is just to remind me what server this is in case something happens that changes the background color. Which it's very rare that happens, but that's just there for just in case. So I use this as a temporary file oftentimes. So in this section, you can use Scrapebox for permutations, or you can just type in keyword permutator out there and find something online. There's plenty of tools. But you could just come here and go comma FL space, or comma space FL space FL. You could go space Florida. And actually, you might not, I don't think you don't need to put spaces, because it'll put a space there. So yeah, you have to do some cleanup afterwards, but let's just do comma FL, and then we'll do FL, and then we'll do Florida, and then we'll do comma space Florida, and then you just come here, go to merge, and then you just find that file, blue server, and it permutates all those. The file I have is bigger because it includes zip codes. And that's a tool that I've shown you guys before. I'll put it below in my comments, Zip Cities tool. I need to find something else that does this also. Basically, you can just put a zip code in here, and then you can just have it go state abbreviations, name, zip codes. The zip codes is really the thing of, the particular value, but it's also valuable to get locations in a radius using this little tool that I have. So I'll try to remember to put that in the description below. And then, so we have these permutations, and as you can see, there's a space after the commas. All you'd have to do is copy these, come into a text file, and then tell it to go Control H, find space comma, and replace it with just comma. And that'll correct a lot of those aberrations or whatever. I use find and replace constantly. The text form of it is much faster. It's like instantaneous if you do it in a regular text file, as I've said in previous videos. And then with Notepad++, you can also do Control H and use regular expression to find very unique things, and you can basically clean data using Notepad++ by using regular expression, and so that's a unique use case for Notepad++. Also, you can change the encoding or look at the encoding of a file using Notepad++ in the event that there's aberrations to your text files and you can't figure out what's going on. That's happened to me a number of times recently. As I mentioned in the previous video, it happened to me, and that was really useful. So this is one way to do location-based filtering, is to create these permutations and then to go into this region, paste those in. You want to create you don't want to do things like FL, comma FL, or just Florida, because it can be way too broad. You don't want to do large-scale location lookups. You really want to do permutations of very specific locations and on-page expressions of those locations. You don't really want to do just cities either, because again, that could pull. In previous videos, I've shown cities that would be like Indiana, Pennsylvania. Like there are the names of these cities and even these states that are in completely other locations. So you really want to do something as precise as you can with the variations expressed in this file, and then pasting the zip codes in is helpful also. So this kind of this kind of targeting, basically, you put this here, skip pages not containing. You don't want to run more than 150,000 URLs at a time, otherwise the threads will get locked and it just won't operate properly. But this will get done pretty, within a number of hours or whatever. And this is the kind of yield that it creates. Let's see here. So this would be an example of how this file yielded, which was 242,000 emails, which is pretty large, actually, from that URL sample. And then I think I scrubbed the duplicates down to 70 some odd thousand, and then once I verified, it went down to like 30K, 35K, which is a really strong sample, especially for a locality, especially for just like, a small target area. Of course, the power there is the number of niches we're targeting in that area. So that's a strong yield using that particular method, which is, I guess you could describe that as a sort of broad locality filter. You're going to have some pretty good targeting there, but there's still room for abnormalities in, unexpected locations. It's hard to say what the percentage might be. Not every website is going to articulate its address in the way that you would expect. So it's really hard to judge. So let me show you now the address variation. So under the way that I've been doing it recently is using the custom data grabber. And when we open up this, let me paste something in here. When we open up this utility, we can take a look at the masks, and you can see how I entered in that regex there on that pastebin file. So that regex, this one here. This one was the one that I arrived at one point, but then I found out that it froze at about 70K URLs or something like that. And so this is basically a shortened version of this. And the main difference, I think, is about here. It basically doesn't start to look for an address unless it detects 2 digits. So any address that just includes like a single digit, like 4th Street, for example, it won't pick those up. So it makes a little bit of a sacrifice, but it runs a lot more quickly, and it doesn't freeze. And the majority of addresses are like 3 or 4 digits anyways. So that's the best address right there that will not freeze in Scrapebox, at least so far. And that's what I'm running here. So I got that there. Here's like an example of an address that would be ideal, and that's pretty much it. There's some other things that you can express here, but and you want to save URLs with those things. It'll extract those addresses, and then the yield looks like this, and it'll have the address, it'll have the URL, and then it'll have the address, and it's capable. That regex is capable of picking up variations like commas and spaces, and so it works pretty well. But the anchor for that pattern is the presence of a zip code, because in the tests that I did with some folks working with me, we found that almost always, if a business was going to express their address at all, they would put some variation of the state and the zip code. And so then once you have your yield, in this case, it would you would just drag your text file into this region, or well, not into this region, but you would open up a premium email scraper plugin instance for the email filter, and then load up your address just file, and then you would paste in your zip codes. So you can use your temp file. In this case, you can just copy that data. Now this obviously, or not this, wait a second, not this version, but the I like to create a permutations file also with, for that broad scrape. And so in this case, you just copy all these, drop them into an instance and say, remove URLs containing FL, and then it'll take out all those those text-based locations, and then you'll have just your zip codes. And you can use the Zip Cities tool to to populate those zip codes in that radius around whatever zip code you put in. But you grab your zip codes and you drop into the keep emails containing, and then that'll be a bunch of your zip codes. Click apply. It'll freeze for a second and process, but this is capable of processing very high number, and I haven't had any issues where it didn't work or it crashed. It freezes, or it appears to freeze, but it's working. Excuse me, it's working in the background. So this is a great filtering utility for only targeting the addresses with the zip codes. And in this case, I actually ran this one recently, and I misplaced my file, and so I had to refilter it. So we went from 68K addresses with URLs that were just generally scraped, right? And then when I save this, let's see how many we get. Let's see, it should be, what's the name of this? Let's copy this. We'll call this address, or let's call this URL and address filter for zip codes. It's kind of a long file name. So that's going to save. Down here, let's open this up. And is this in here? Let's see. Yeah, that's already in there. It's a good idea to keep workflow files. I like to keep them in zip folders and then throw them somewhere. So this file has 68K. Okay, I must have done the filtering on this and then saved it as address. So we'll save this anyways. So the bigger file, let's see, how big was the URL file? URL final URLs. Let's see, how big is this? Oh, I see. Oh, you know what? It's not scrubbed for duplicates, just on the URL level. So that's probably why I named that URL final. These are the URLs before any of that. 350K URLs. So that's a big size, and I had to drop that down. So I bet if we drop this file down, it'll equal 20.7K. So let's see what happens. So let's throw this file in, remove everything after this piping symbol, and then we'll scrub for duplicate URLs, and yep, 20.7K. So that's what I did. Then to copy those over to a text file, and Control H to remove all the pipings, period. That way we get clean URL lists. And actually, I wonder if there's any forward slashes in here. Sometimes the forward slash at the end of that, I probably already cleaned them off in some other phase. But anyways, you let me see, let me grab these, copy these, and then drop these in here. Yeah, sort these. Okay, let me save these as final URL from address. I'm kind of doubling up on these things, but that's fine. Like, it's probably not very big. Yeah, it's only like a megabyte each. So we went from using the grab check email utility with their filtering mechanism, giving us about 70K URLs, and then by filtering using the zip codes on the addresses, we dropped down to a hard 20K URLs. Now, of course, the question is, are we getting a better yield with the broader search because those terms are on the page a little differently? Probably so. We're probably also getting some extra things a little bit. It's hard to tell. Um, but then with this particular sample, it's extremely precise to only business types that have a for sure verified footprint of a more fully qualified address on their page. You see what I'm saying? And so this is useful because it's extremely precise. You know what I mean? And so then at this point, I would take this sample of URLs, come into the filter, and clean this out, because if the zip codes are on page, if they have addresses and the zip codes are on page, then we don't need to do any hard filtering. So let's process these URLs, and let's skip ahead and see how it yields. Or wait a second. The broad one yielded, it was 70K males. So it was a much higher sample of URLs. It might have been this sample. I didn't label it properly because I was in a hurry. So it might have been it might have been this one, and I might have just split it up. This sample will yield, somewhere in the vicinity of, I would guess, 10K, and then it would yield. Actually, it's getting given a lot more than that so far. And maybe it'll verify down to 5K. So you're looking at a difference of maybe 5K with fully qualified addresses to 35K with more broad footprints. But the former scrape actually takes a lot more time to process. It's less precise, but it's more generally, and it's more likely to have, general targeting. It's not going to cut things out that belong in the sample, if you guys see what I'm saying. But this is still, in some cases, like in some of the last jobs that I did recently, where I really required super precise targeting. This was an essential method because I was getting things that I would do. Say, I could maybe take the broader sample of mails and URLs, run those through the address check, and then some of those would return fully qualified addresses that had other locations that were not precise. So it's not to say that it's so imprecise it's not worthy of use. Like there's like a middle ground that you just can't quite get into. You know what I mean? Like you can get kind of like 75% of the way there, or you can get like super there, but then you're excluding some larger percentage. And so it's hard to say. In this case, in some of the really specific localities that I was doing, the address method was essential to keep the list as clean as possible. So it really just depends on your use case and how precise you need those locations to be. If you need them to be mostly there, obviously you can just use the typical grab check email filter and do those permutations of cities and states, variations in zip codes and what have you. And that, for most purposes, that's probably going to be pretty great. But then, if you really need to make sure that you're in a very precise location, then obviously you're going to want to use the address method. What's this? You want to use the address method and then filter it for zip codes. And then that way you will for sure be right on the money. Nothing in that sample, well, that sample should be 99% correct, unless somebody maybe has like an address that's exactly like the zip code from some other state locality, but then it's actually for some other state or city. It's possible. It's just a lot less like look at this. 32809 Bell Isle, 32809. Like that's those are examples where it could maybe be inaccurate if the latter zip code was completely different or whatever. So, and you can't necessarily filter by state suffix or state name because it's not always there. You see, like look at how this person they put some kind of address, and then they put Zellwood Christmas Soe, Gotha, Clarsona. They put like a bunch of cities in a row, which is just terrible syntax or whatever it's called, terrible formatting of your address. But hey, it's still gets you that business, and still might get you a contact for that business. Anyways, so that's pretty much the method. Look here, we're almost halfway through, and we've already got 10K emails. Let's skip forward and see how well it does. I want to kind of finish this out, see where we land on this sample. Okay, let's take a look at the results of this scrape. Let's open up the data folder. Looks like 19K males, which is a pretty amazing ratio, actually. It's usually like a third of the URL sample, and then, well, maybe not a third, maybe like half the URL sample, and then like a third of that would be verified. So let's take a look here. Let's get this date modified. Make sure that this is flipped upside down, because this, I need to delete these two. And that's right there. Let's close this. It's a tremendous yield, though, of males. So let's open this up and replace this piping with a comma. And make sure that's... I always need to make sure to check this, because earlier I replaced the piping with nothing, and then I had to do this HTTP and basically artificially insert that in there. What is this? Let's see. Let me get this back up here. So it should be, let's call this, I don't have a taxonomy for address-oriented URLs yet, so let's just call this address, URL, and email. And let's switch this up to CSV. Sorry about that. Let me turn my speaker off. Let me drag all these into the workflow. And then delete these. Copy this over. And let's go to my verification server. And drop this in here. See what we got on dupes. Half the sample is dupes. So that's not bad. And verify. I would guess a third of that. So it's 12K. So it should be about 4K completely valid. So it's 4K. That's about what I guessed it would be, 4K to 5K. And then the other one that we just got was like 30K. So kind of a big difference, but this one is also just, as I said before, it's just exclusively the URLs that had a fully qualified address. So if you just wanted to be really precise, this is a pretty cool method. Let's skip ahead and see how our yield turned out, and then we'll end the video. Okay, so that one finished. Looks like 6K valid emails, a little bit more than what I estimated. So that's nice. And let's go ahead and export this into this right here. We would probably need to call this address verified, since this is slightly different. Let's delete this and open this up and replace these semicolons with commas. So that's pretty much it. 6K to 35 some odd K. You can filter by permutated locations and zip codes on the email, or you can filter. So the thing with the email is that'll get you those that'll get you those broad locations. Let's see. Under the email section, this will get you the broad locations on the URL, the broad URL level. You can then take those URLs and then you could technically scrape for addresses or phone numbers and, of course, emails after you've collected the emails using this. This utility right here, this scans the pages for, it says, skip pages that don't contain these footprints. So when you use this filter, it's kind of like a combination between the page scanner and the email scraper, because it does like a mini page scanner before doing the email scrape. So if you wanted to do a broad, page scan before doing the emails, you could come to the add-ons and do a page scanner for those phrases. You just edit the platform mask, make a new one, and my email checker just has the ampersand, for example. Pretty sure you would just put line by line those locations, and it should work the same way. And so that might be a pretty good way to do location filtering at a broad level with the page scanner. You could include that in the automator before exporting your URL sample. That would probably be a good way to do it before, so that you wouldn't have to do it with the email grab check, because I don't think that the automator gives you that option to set a filter. It might, but I know that there's a filter section, and they make you do it like inside the automator file instead of looking at like a static file name. I think there might be another static file name feature. I've seen something like that I've used in some processes. So something to think about and look into. But in some cases, you would want to get a sample of URLs that's even more precise to the location, and that's where, doing a grab check for the address comes in handy. And then you can actually cut everything before the piping. So cut everything after the piping, I guess. Yeah, you can cut the address out, and then you can just isolate those URLs. That's what I was just doing basically there with that new address URL sample. There is basically scraping for the address first, so that you could get more. You could filter those addresses down to the zip code level, and then you could take those URLs and you could use those URLs to do your email scraping or your phone number scraping or whatever. That's like an even more, I guess what I'm trying to show you guys, that's an even more precise local scrape variation. So I know there's a lot going on there. I'm sorry if that was a little bit confusing, but those are two like viable methods for honing in on an area. And let me think. Do we want to end it there? We could do a test where I show you guys. Let me see. Let me look at my workflow file, because it might be interesting to show you guys really quickly the difference between these two. Because the final URLs from the addresses, that's 20K, and then I think this is after. Well, this sample could not be filtered topically. That's probably why the URL sample is so large, because the topics there's 1,000 topics, so you can't filter at the metadata level like you can with a lot of niche to niche scrapes. And so that's why this one was more cumbersome to process. Now, in order for me to get a precise yield from this sample, I would have to use the page scanner. Let's do that real quick. This is not something that I test. I may have tested this in another order, which is why the other day I had to come up with a more precise method using zip codes. But it's been like a week since I did that, so I'm a little bit rusty on my own thing here. These are the new ones I saved, and all the other files are in here. Okay, so let's take this URL sample, and what we'll do is we'll run Page Scanner on the permutations for addresses and specific locations. So these include, let's see, Florida, FL. Oh, these don't include the comma variations. How big is this? Yeah, 520. So that's why this particular file isn't as big. So I need to create some different variations on this list before we run this test. This will be really interesting. Might take a minute for this to roll. Excuse me. Let's open up the add-on here for Page Scanner. And let's go. Let me look at the settings. There's only 200 connections here. It's such a drag. It's just kind of arbitrary how they have different sections. One's like 200 connections, the other one's like 500 connections. I wish I could just set my own connections, and because like I've only got like half the resources utilized at any given time. I know I could get a little bit more. Anyways, so let's throw these in here, and then I wonder if these are. I probably filtered for. I probably did a page scanner filter on the ampersand for these to drop the list size. So those have males on them, which is why I was able to pull, or some kind of ampersand. I was able to pull like 250K. I'm trying to think if I want to do. This is kind of a big sample. We don't really need to test this sample that large. But this broke down to those. Well, we need to test this because this broke down on the address level to a much smaller number. So we do need to test this just to see how many of those locations appeared on page. So let's edit this and let's go new. Let's add sorry. Keep turning this back on while I'm waiting. Let me add all right, let's add these. Actually, let's do this change here. So in this section, what we'll do is we'll copy this, and then we'll do a Control H. We'll find space FL and replace it with comma FL. Place, is that case? Yeah, we want to match. We want to make sure we match case, or else it'll it won't work properly. So we match that. Make sure the Floridas aren't. Yeah, the Floridas won't be touched because we matched case. We also want to come in here and we want to go space Florida to comma space Florida. Place all. And we'll check it out. Looks correct. And then down here at the bottom, we'll repaste the originals, copy and save. We'll come over here to our second Scrapebox instance, remove duplicates, and that gives us 704. So let's paste this back in, and now we have all the variations that are typical. And so then we'll come in here and we'll paste all those into this section and simply hope, okay, that it doesn't crash. So we'll call this one locations. And let's turn this one off. Well, actually, you know what? We could run two at the same time. Yeah, we could do locations with ampersands also. That's a cool idea. Oh, wait. We don't want it to be one or the other, though, because that's okay. Because I think I already ran that. Anyways. So let's just do locations, and then because if we did the ampersand, then it would just return everything probably. Okay, so then we'll load URLs. It's kind of big, and hope that it just doesn't take too long. Let me think about this. So I want to compare. Let's see. Where's my other sample for? I really wish that this would be global. new computer, so let's do that. Okay. So address, URL, and email. Final URL from address. Those should be the same. Let me take a look at this. Should be 20K, yeah. I could run a test on just the root URLs just to see how it compares. I know that this is going to take a while, but it's a test worth running. So did I put this in here? Let's see. Let's just go ahead and run it. This might take forever, but it's fine. Okay, start. Hopefully it won't crash. Let's see how it does. We're at 357. Let's see how long it takes to get to 1%. Sure is responding slowly. Oh yeah, this server will probably crash. It's not really good for it to run that high, that constantly. The rules must be just too. All the locations must be just too numerous. That's gonna take a couple hours. Well, oh, there goes the 1%. Well, we'll see if it doesn't crash. I'll try to pause it, come back in a couple hours, and see what happens. I guess the purpose would be to figure out what is the percentage of location oriented URLs. The yield for mails with those location footprints was 70K ish. So we know that it's at least 70K, not counting ones that didn't have mails. So that's at least like 2.5 times more prolific than just purely address. So anyways, something to think about. I'll probably just end this here. Thanks for watching, guys, and please leave me a comment, subscribe, let me know your thoughts, and let me know if you've got any interesting use cases for doing a specific location. So I'll catch you later. Bye-bye.